Okay, well, I'm ready now to embark on a series of tests for optimization of the fan-driven smoke and the Smart Smoke system for the vintage metal flyer smoke housing as well. Some know that we're using a device called a thermistor, and it is a type of a resistor that decreases it increases its resistance as it gets hotter, or as it decreases. I think it decreases. I don't remember. I'll explain it another time. Anyway, then we have the heater, which actually vaporizes the oil and creates the smoke. In this case, there's a piston going in and out of its shaft as the motor turns. In this case, there's a fan which is triggered by a trigger, pulse switch, cam, something to push air through. It's called a fan-driven smoke. And what we're trying to do is accommodate the alignment, the arrangements between the two, but the distances and the positioning and height, and also there's a reference resistance that we have to determine, and all of these are connected with variables such as airspeed, the voltage of the fan motor, capability of the heater, how much oil is in the piece, and how much voltage is on the track versus how much voltage is getting to the thermistor. And we have to try to balance all of these things out so that regardless of how it's operated, we get good smoke at low speed, high speed, and we don't burn things out prematurely or melt things down prematurely. Our housing here is carbon fiber impregnated PETG. It has a very high temperature rating, but around 180 degrees C is pretty doggone hot. And as you can see, we're sitting right now at 125 just out in the open. If I blow on this for a second, you'll just see just a puff like that brought it down to 95 degrees and the smoke would stop. So if you can look in here and see that little piece of fuzz on the far right pushing out when I press this, there is airflow. Air is coming in, and that air would cool this heater down. And so we have to have enough voltage to create enough heat so that even with the airflow, we're still getting enough smoke coming out. That's the whole exercise here. And I've constructed this for numerous experiments over time, but now this is one of my main experiments. This is the most instrumentation I've done. I have a switch for the fan motor. I have a fan motor power